This is part 2 of paper 1, June 2023, question paper hired to AQA GCSE physics. Here on question 6 we have a graph plot for a filament lamp of current against potential difference. We have an IV characteristic graph, and we should describe a method that the student can use to obtain these results, included a circuit diagram. So to contain these results, we obviously need an ammeter to measure the current and a voltmeter to measure the potential difference. So let's start making the circuit then, shall we? Pick black. Yep. So let's have a power supply like this. We're going to need a variable resistor to change the current in and the potential difference across the filament lamp that we have here. We have an ammeter to record the current in series. We have a voltmeter up here. So let's write down what each part does. So ammeter measures current voltmeter measures potential difference. Let's write PD. And the variable resistor will vary the current in. Current in and potential difference across the filament lamp. I'll just use the symbol for filament lamp instead. To get the negative values on this graph here though, we're going to have to reverse the connections to the power supply. So let's write that down. To get negative values, we reverse connections to the power supply and we take readings and calculate a mean. And there should be your 6 marks. Next question. Determine the resistance of the filament lamp when the potential difference across it is 3 volts. Use the physics equation sheet. Use figure 6 on page 18. So let's go back to this graph. This is figure 6. It said looking at 3 volts, so that's going to be over here. Going up from there, we seem to be getting 0.16 amps as a reading. We know of Ohm's law, So we can use V equals IR. That's probably what they're hinting at by telling us to use the physics equation sheet. We know the voltage is 3. We know the current is 0.16 times R. Therefore, R is just going to be 3 divided by 0.16. Throwing that into your calculator, we should get 18.75 ohms. Next question. The current in the lamp is 0.21 amps when the potential difference across the lamp is 6 volts. Calculate the energy transferred by the lamp in 30 minutes. So here we have to use two equations, it looks like. We're not given, well, we know that energy transferred, E equals QV, but we don't have Q, so we need to find Q. And the only other equation that we know got to do with Q and current. Q equals IT. Given time, given current, given volts. So let's calculate Q. 0.21 times 30 times 60 to get that in seconds. 60 seconds in a minute. Therefore, Q is going to turn up as 378 coulombs. Therefore, the energy transferred is going to be 378 times 6.0 volts, which is going to be just 2,268 joules. Next question. Alright, 6.4. The power output of the lamp is 1.0 watts when the potential difference across the lamp is 5 volts. The student predicts that the power output would be 4.0 watts if the potential difference was doubled. Explain why the student is not correct. The student is only going to be correct if this is true, then since we know P equals VI, both the voltage will have to double and the current will have to double if the power goes up by 4 times the amount, as we can see here, 1 watt to 4 watts. If this is the case, then voltage would double and current would double. But looking on the graph over here, we can see that current is not quite directly proportional to the potential difference. So on graph, current is not directly proportional to the PD. And there's your 2 marks. Okay, we've got some babies here. A baby bouncer is a harness attached to a spring that hangs from a door frame. Shows a baby bouncer in 2 positions. Cool. Baby bouncer should not be used with babies that have a mass greater than 12 kilograms. Just one reason why. Well, I'm immediately looking at this spring that we have over here, and this spring will probably break, or a better way to say it is just that there's going to be a permanent extension. So let's write that down. Spring permanently extended. In positions A and B, the baby is stationary. Describe the energy transfers as the baby moves from position A to position B. So when we think about energy transfers, we think about gravitational potential energy, we think about kinetic energy too. We can also think about elastic energy in this case because, well, we have a spring. So the baby in position A is going to have gravitational potential energy because the baby is off the ground. But to get to position B, the baby has to be moving down, so that's going to be some kinetic energy. And when the baby is fully at position B, the energy transfer will also go to kinetic energy over here. Not kinetic energy, sorry, elastic energy over here to the spring because the spring is now extended. So let's write that down. So at A, it's all just going to be gravitational potential energy. To get to B, it's going to go to kinetic energy and elastic potential energy. And then at B, it's going to sorry, yeah, at B, it's going to just be another change in gravitational potential energy again. Sorry, it's going to be fully in elastic potential energy because there's nothing holding the baby up apart from the spring, and the spring is fighting gravity to do so. So this is going to be full, that's going to be full, and yeah, your 3 steps. At A, fully gravitational potential energy. At B, some kinetic energy and some elastic potential energy. And then at B, it's going to be fully elastic potential energy. Okay, next question. In one position of the extension, the spring is 8 centimeters. The elastic potential energy stored by the spring is 4 joules. Calculate the spring constant of the spring. Use the physics equation sheet. Looking at the equation sheet, we'll get the elastic potential energy coming out as half k E squared. We know that E is going to be 8 centimeters, which will be 0.08 meters. Therefore, the elastic potential energy we know is 4 joules. So 4.0 equals 1/2. Got to find the spring constant. Leave that as k times 0.08 squared. Rearranging for k, we should get a value of 1,250 newtons per meter, sorry. 1,250 newtons per meter. Scientists developed new models of the atom as new particles were discovered. Draw one line from each particle to the year it was discovered. Electrons were discovered first because, well, they're very easy to discover. They're negative and small, H97. And the nucleus, if we remember the plum pudding model, was the next hypothesis and theory about the atom. Protons are next because they actually have a charge like the electrons and were much more easier and identifiable to pick up than neutrons that were discovered last in 1932. The nucleus was discovered using an alpha particle scattering experiment. Alpha particles were directed at a sheet of gold foil. We have alpha particles A through G, and we have a gold nucleus up here. Explain why alpha particle A takes the path shown in figure 8. As you can see, alpha particle A is deflected from the gold nucleus, and it appears to be being repelled. And we know why it's repelled. It's because both the alpha particle and the gold nucleus and the net and the net positive gold nucleus gold nucleus both have positive charge, therefore they repel. This in and of itself is a mark saying that they repel, and here you just have to say that they both have the same charge, positive charge. 8.3. Explain why the path of the alpha particle B is more tightly curved than the path of alpha particle C. Well, we can see that B is much closer than C is to the gold nucleus. So B closer to nucleus than C. B is closer to nucleus than C. Therefore, B experiences a stronger repulsive force. A stronger, or you can say electric field. But I'm just going to put down a stronger repulsive force, because it's just easier to remember for me. And probably for you in the exam. Depends on what you want to do. What can be deduced about the atom from the path taken by the alpha particles D, E, F, G? Well, we know that A was fully deflected, B and C curve off, and D, E, F, G, if you look back again, they just pass straight through, straight as an arrow. So we know from that information the atom is mostly empty space. How is the Bohr model of the atom different from the nuclear model of the atom? The Bohr model of the atom suggests that electrons orbit the nucleus at specific distances, whereas the nuclear model of the atom, I'm pretty sure, orbits the electrons orbit at continuous distances. It's like a continuous range of distances. Orbit nucleus at specific, important word here, specific distances. Explain how an electron can move up and down between energy levels in an atom. So this is talking about the excitation and de-excitation of electrons. Electrons are excited when they absorb energy in the form of EM radiation. And they also emit energy as EM radiation when they move down energy levels. So this is to move up between energy levels. This is to move down between energy levels. And there's your 2 marks. Next question. Question 9 now. Figure 9 shows air being bubbled into a car tire. Complete the sentence. Air particles in the tire move quickly in. What do you know about air particles in a gas? They move quickly in random directions. It's one of those things you need to always know. 9.2. When the tire is at the correct pressure, pumping more air into the tire causes the pressure to increase further. Volume and temperature of the air in the tire do not change. Explain why the pressure increases as more air is pumped into the tire. Well, there's going to be more air particles in a unit volume, and therefore there will be more collisions too, specifically collisions with the tire walls. Hence the pressure rises. 9.3. The air pressure in a car tire changes if the temperature of the air in the car tire increases. Explain why. We know when the temperature rises, the particles are going to have a greater mean kinetic energy, And when this happens, they tend to there tends to be a greater number of collisions. So the number of collisions increase with tire wall. And we also know that the force of these collisions also increases too. Force of collisions rises. And finally, since we know that pressure is force over area, we can write this down and just say, therefore, pressure increases. As there is greater force of collisions per meter squared, I guess you can say, because it's in pascals. So yeah, and I think that comes to the end of part 2 of the paper. Like the video if you enjoyed. I'll try pushing more of these out. And yeah, enjoy your day. Thank you for listening.